Today's lesson in trigonometry was about functions. Here's the page number and the problem number. We're going to talk about determining whether an equation represents a function and evaluating functions and simplifying, including completing a table. These are from your book if you want to read through the definition of a function. But basically the most important thing about functions is that this one right here. An element in the domain cannot be matched with two different elements in the range. This is the vertical line test on a graph. If a vertical line passes through more than one point on a graph, then the graph does not represent a function. So it's only a function if each element in the domain has its own range value. Okay, for example, using the vertical line test, if you had a graph like that was linear, that one is fine. That's a function. If you have a parabola, that's a function. That's fine. If you have an exponential graph, that's fine. If you have, let's say, even a semicircle, that's okay. As long as if you had a vertical line, let me get a vertical line right here, and you were to move that vertical line left and right, it will never pass through the graph more than one place. See right here, it never passes through the graph more than once. Same thing here. Now there's places where it doesn't go through at all, but as long as when it's on the graph it doesn't go through more than once, then it's okay. However, when you have certain graphs that are things like a circle or maybe a sideways parabola or even any kind of, weird squiggle of any sort, all right, those ones are not going to be functions because if you have vertical lines, it will pass through the graph more than once. You can see right here and here it passes through. Here it only passes through once. But because at some point on the graph it passes through more than once, it's not a function. Same thing with this one right here, this one right here. I mean, there are some places where it only goes through once, but since there are some places where it goes through more than once, that's not a function. Okay, so that's what it is with a graph. Now, what if you have an equation? Okay, let's take an equation right here. In order for an equation to be a function, it has to be just y equals something with x in it. Like you could have a linear equation, you could have a quadratic equation, you could have all different types of equations, absolute value, all right, x minus 3. These are all functions because they can have different y values, but only one x value for each of those. Now, things that are not functions would be things like if you had y squared equals x plus 3, or if you had absolute value of y equals just anything, x plus 3. Now the reason for this is because if you think about it, these ones are already solved for y. So the y value you get, you're going to get a single y value for that x. But on these ones, if you were trying to solve for y, let's just take this one for example. If you were trying to solve for y, you would have to square root both sides. So if you square root both sides of the equation, then you end up, anytime you square root both sides of an equation, you have to make it plus or minus. And the very fact that you have to change it into plus or minus means you've changed it into two separate y values. There's a y value that's a positive blah 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 and a y value that's negative blah blah blah. Same thing with absolute value. If you have absolute value of y equals x plus 3, then when you break it out of the absolute value bars, you have to break it into two separate expressions. So there's the y equals x plus 3, and then the y equals negative x minus 3. And so you have two separate y values. So anytime that you have an equation, a y equation where you have a y squared or an absolute value of y, that doesn't represent a function. It's okay if the x is squared and the x is in absolute values, as long as the y is not. Another example of something that's not a function functions would be even if it's just y equals a number, because that's a horizontal line. However, if you had something like x equals a number, that is not a function either because that's a vertical line. You can't solve for y, so that one's not a function. Okay, these are the problems from your book that are based on this. So basically you can just look at these and say, okay, is the y squared Like this one right here, because it has the y squared, that's not a function. Because this one has a y squared, that's not a function. Here, the x and y, the y is not squared, so this one is a function. This one right here, the y is not in absolute value, so this one is a function. But here, this one, the y is in absolute value, so this one's not a function. Okay, now let's go to the second one. Now, evaluating a function, you've done this for years. I mean, every time that you've been in an algebra class, you've had to, even in Algebra 1, you had to plug numbers into a formula. So that's basically all this is saying, just plug the numbers in. All right, the one that we did in class right here, you just plug the 4 in for y, then you plug a 0.25 in for y. Let's do this expression right here, though. Okay, let's do f of -8 for number 30. Basically, this means that you're going to substitute in place of the x, you're going to plug in a -8. So -8 plus 8, oh, you know what? I made that bar too long. Okay. All right, and then the plus 2 on the outside. So this right here would be absolute value, or I mean, sorry, square root of 0 plus 2. So that's 2. All right, that's one answer. That's the answer for A. If you were doing f of 1, that would mean that you would do the square root of 1 plus 8 plus 2, and that square root, that would be square root of 9 plus 2, which is 3 plus 2, and that equals 5. All right, so so the answer for A is 2 and the answer for B is 5. Basically, this is just saying that this answer right here, if you plug 1 in for x, then the value of the function is this. And if you plug in -8 for x, then the value of this function is this. Well, what if you have an expression? You do basically the same thing. Get rid of this right here. You do basically the same thing, it's just you have to simplify it. So here we go, f of x minus 8. I'm going to take that whole expression and plug it in for the absolute, or into the square root. So the square root, it's something plus 8, but the thing that's going to be plugged in is the x minus 8. So we end up with, if we simplify underneath here, that would just be -8 plus 8 cancels out to just 8, and then you just bring down the 2. So where's that? Okay, there we go. All right, so the function value for this ends up being an actual function itself, square root of x plus 2. So we went from this function right here to another one that's slightly modified. Okay, so on all of these, like the A and the B are pretty easy. You just plug the number in. On this last one, you have to plug the expression in and simplify it, and you're going to get another expression. All right, now when we get to this part, this is actually the easiest part right here, because all you have to do is take each of these numbers in the table and plug them in. That's all you got to do. So, for example, this one right here, all you got to do is do the square root of 3 minus 3, which is the square root of 0, which is 0, so this value is 0. Here would be the square root of 4 minus 3, which is the square root of 1, which is 1. And, you know, sometimes it's not going to come out evenly, and that's okay. This one will be square root of 2, which is, we're just going to leave it, square root of 2. So anyway, just fill in the table. Go ahead and leave it as a radical if you need to. This is nothing more than just filling out a table of values. The operations look a little more complicated, but they're really not. Okay, now don't be afraid of number 99 and number 100, because I picked them out specifically because you just have to plug numbers in. Okay, so all you're going to do is take these different values of n, and you're going to plug them in. Okay. Write the revenue as a function of n. So for groups of 80 or more people, a charter bus company determines the rate per person is this. So basically all you do is you plug those in. Using the function in part A, what can you conclude? Well, just plug them in and see what you get for the answers. Okay, same thing here. I know that this looks like a really messy, ugly formula, but I mean, in the real world, that's what you have. You have really messy, ugly formulas. So you have to know how to deal with them. All you got to do is just plug each of one of these into this mess. Okay, I'll take one for example. Let's just do 20. So you have 149.76 times square root of 10 times y to the, well, it's y to the 5/2 power. And so we're going to take, instead of y, you're going to plug in a different value. So I'm going to plug in, what did I say, 20? So I'm going to plug in 20. Now, how do you do 5/2 power? Well, you want to pull up your calculator. So let me get the calculator right here. Whoa, okay, hold on a second. There we go. Okay, pull up the calculator. So I'm going to be plugging in, oh, sorry, it keeps doing this. Okay, Travis, figure it out. Okay, 149.76, all right, times the square root of 10, all right, close the parentheses, times 20 to the power of, and you have to make sure to put that fraction in parentheses, to the power of 5/2. Okay, let's break this down. We got 149.76 times square root of 10, close parentheses, times 20 to the power of 5/2, because that's what the formula said. All right, you're going to get some decimal, and that's okay. All right, so we're going to end up with, what was that again? Let's see, about 847,170, 847,170. Okay, so that is going to be the value for 20. So these numbers are going to be kind of big, so you have to make your this kind of big. Now use the table to approximate the depth at which the force is 1,000,000. Well, at some point in this table, it's going to be close to 1,000,000. For example, this is already 800,000 when it's at 20. So somewhere higher than 20, somewhere in here, it's going to reach 1,000,000 or about 1,000,000. And so what you're going to do is, and now you guys don't have to do C yet. Save that for tomorrow, but you'll just estimate what the y value is that would be about 1,000,000. So anyway, don't get freaked out by these formulas. It's just filling in the table and answering the questions using the table. See you tomorrow.